Assalamualaikum and good afternoon. So today for this video we'll be we try to solve for the cam design. Let's refer to this question from the problem that I have uploaded, which is 9.96. A cam drive is used for a mechanism that drives an automatic assembly machine. So the cam follower must rise outward 13 mm with constant velocity in 3 seconds, then dwell for 3 seconds, fall 5 mm with constant acceleration in 2 seconds, and then dwell again for 3 seconds, fall 8 mm with constant acceleration in 2 seconds, and then repeat the sequence. So now first we have to draw the displacement diagram, right? So first to do that, we have to prepare a table which describe the motion here. Let's draw a table, a simple table perhaps, which have a displacement, time in second, cam angle, and then the type of motion. So first we have rise outwards 13 mm. So first is rise, so just put it on the side here, that will be enough. Okay, first is rise 13 mm. The time is 3 seconds. We yet to calculate the cam angle, and motion is constant velocity. Right. 1. Then we have dwell for 3 seconds. Dwell time 3 seconds, and then from there fall 5 mm. Constant acceleration in 2 seconds. 2 seconds, constant acceleration. Acceleration. Then we have dwell again for 2 seconds. Dwell 3 seconds, and finally fall 8 mm within 2 seconds with constant acceleration. So now the total time we have to calculate. 3, 6, 8, 10, 13 seconds. Okay, once we have the total time, which is 13 seconds, then we can calculate into the angles. So 360 degrees divided by 13 is equals to 27.7 degrees. This is per second. So for 3 seconds, it should be 27.7 times 3, which is 27.7 times 3, 83.1 degrees. Next dwell is also 3 seconds. So 83.1 plus 83.1, so in this case just times 2, which is 166.2 degrees. Then here 166.2 plus 2 times 27.7 plus 2 times 27.7 is to 221.6 degrees, then plus 3 times 27.7. In this case it is 304.7 degrees, and plus again 2 times 27.7, which is 360.1 degrees. Well, we can basically ignore this 360.1. So total is basically 360 degrees. And now to plot it on this graph paper. So I prepared the graph paper already. So since the rise is basically 13 millimeter, I put this at 10 to 20, and then in terms of angle, every two small blocks I put in terms of 30. That means every small the small one should be around 3 for each increment. Okay. Now for 3 second is equals to 83.1 degrees. So if I here, so this is 75, 78, 81, 84. We just take basic here, and for 13 will be somewhere here. 10, 12, 13 will be in the middle. So we can plot this. 13 in the middle here. Okay, that will be the one. Next is 166.2. We will dwell for 3 seconds. Okay, 166.2, 166, 150, 153, 156. Okay, 153, 156, 159, 162, 165, 168. Somewhere here. Okay. Okay, this is about 166.2. You don't have to be really accurate in this, as long as we get the because in the end it will not be it's all basically having a lot of approximation. So next is fall to 5 mm at 221.6, 221, okay, 213, 216, 219, 222, somewhere here. Okay, and at 5 will be somewhere in the middle here. Okay, and then next is dwell again at 304. Will be approximately here. This for 5. Okay, and next is okay up to the end, which is here. So we can draw a very since this is constant velocity, you can just simply make a straight line here, no problem. This is well-defined line, and then dwell. So it's already a straight line here. Problem. And so dwell here also. Okay, but this one we need to create into thin line first as a guide. Okay. So this is this part is constant velocity. Okay, dwell, constant acceleration, dwell, and then constant acceleration. For constant acceleration, we need to basically divide into two parts now. Okay, we have to define how much will be I mean, when you two parts, which is the upper and the lower one, where you have the acceleration and deceleration, and the same thing here. Now we have to do that. Okay, now we need to find the midpoints for this constant, for this both constant acceleration motion. Right. Here is 13, here is 5, so that's 8 basically. So we need to find the midpoint. This is 13, 11, and then 9. So we fall somewhere here. So that can draw the midpoints. The midpoint 9. We can have it into 4 parts. This is the horizontal one and the vertical one. I mean, sorry, the vertical one. This is vertical. Okay. And the horizontal one. So we can estimate it to be somewhere here. Okay. So from this line, we need to create sorry okay, sorry, it should be actually starting from the middle here. 1, 2, 3, 4. Okay, so you need to draw the straight line. This, 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 same part here. So this is the first point, second point, third point. Okay. So now it will become this. Okay. So for the next one here, which is between 5 to 0, so the midpoint is 2.5. Just need to find the midpoint here. 2 point. This is 2, 3, so it's somewhere here. Right. This is the midpoint. So we draw the midpoint line here. So we have to basically divide by 4. We can estimate really. Same here, we can divide by 4. Okay. draw the straight line. This one, 1, 2, 3, 1, 2, 3. Okay. Then we draw this line. Okay, so you know that this is the first point, the first cross line with the vertical line, second point, third point. Okay, of course, put the point, first point, so with that we can draw now the shape. Now we have the parts now, which is constant velocity, constant acceleration, and also constant acceleration. So next that we're going to plot basically the radial, which is the profile. We're going to plot the cam profile on the radial plot. On the polar plot, polar graph paper. So before that, we need to basically identify what will be the, for each of the basically at 90 at every 30 degrees, what will be the displacement, right? So with that, we try to point it out here. 90. Of course, it might not be that accurate, but it's okay. With that, we can get the value, which is 24. 2.8. This is about, sorry, 4.8. It's about 5, right? 4.8. At 60 degrees, it is about 9.4. And 90 degrees is 13. 120 is 13. 150 is 13. Okay, 180 is equals to 12. 80 to 10 is equals to 4. This is 5.8. 5.8. 240 is 5. 270 is 5. 300 also 5. 330 is 2.5 maybe, and a 0. Okay, now we have the full data for the displacement diagram. With that, we'll be able to basically plot the polar paper. Okay, now we have all the data, all the displacement at every 30 degrees. Then we can start draw on the polar graph paper. Okay, before that, since the question did not actually address for you or require of you to draw a cam profile, so some of the information are not actually given. For example, the direction of the rotation, and then the base circle dimension and so on. So in this case, let's say that the base circle's length is about 10 mm. Okay, 10 mm, just for the sake of trying to do this, 10 mm. So we know that we have to count up to 10 before we start to do all this part first. Okay, so this graph paper is every 15 degrees, but what we have here is every 30 degrees. So we have to skip one line basically. So this is 0, this is 30, this is 60, this is 90, this is 90, 120, 150, 180, 210, 240, 270, 300, sorry, 300 here, and this 330. Okay. Right. Then 360 over there. Okay. So let's just draw the, not really draw, but allocate the 10 AM first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is here. So this will be the base circle. Let's just draw that to make it proper. Gosh. Okay. Now, so for 30 degrees is 4.8. So this is starting from 0, 30 degrees, starting from here. 1, 2, 3, 4. 4.8 will be somewhere here. Okay. 60 degrees, 9.4. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9.4 will be somewhere here. 90 degrees at 13 already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Will be it. 120 also 13 until 150 also 13. So 120, it is on the same line here. 13, 150, and for 180 is 12. 180, so this is 13, 12. Then we will drop to in 210 and 5.8. 210, 1, 2, 3, 4, 5. 5.8 will be here. Then 240, 270, and 300 will be at 5. 240, 1, 2, 3, 4, 5. 240, 270, and 300 will be at 5. So next is at 2.5 at 330. 1, 2.5. So with that, we can now draw the cam profile. So it will be something like this. Okay. So this will be the cam profile, the resulting cam profile. Of course, if you actually want to have a much better profile somewhere here or here or here, you can actually increase in terms of the resolution of the degrees. So instead of every 30 degrees, you can go to 15 degrees. But in this example, I just stick at 30. And even for the exam, I'll just take 30 is good enough. Because to do more than that, it will be taking too much time for you to spend in terms of solving the problem. Okay then, so we have this profile. And this is the answer. See you again for the next video.